Steel. It touches our lives every day in the cars that we drive, the buildings we live and work in the appliances, machines, and materials that make our modern lives easier. ArcelorMittal is the premier steel manufacturer and one of the biggest in the USA. But to maintain this critical business, we need to constantly maintain our mills. And now, we're looking for bold, skilled, and knowledgeable individuals to help us do that and carry this key industry into a successful and sustainable future. At ArcelorMittal, our people and their safety is our #1 priority. We conduct pre-job safety meetings. We identify the hazards in the job and put controls in place to maintain safety. These controls are used at all our plants and by all the employees in this video. Employees who work hard every day to maintain the equipment that allows us to produce world-class steel.
Hi, I'm Yolan Sobkowitz, MTM at ArcelorMittal, Indiana Harbor. Every day is different. It's never the same routine over and over usually. So you have something new and challenging every day. We're going to pick this mandrel up and we want it to be level. So we have to do some calculations on how much it weighs. We have to figure out the center of gravity and also figure out what size slings we can use.
Yolan knows that she must first find the volume of the cylinder. The equation for finding the volume is pi times radius squared times length. Once she has calculated the volume, she will multiply that number by the weight of a cubic foot of steel. That will be the rough estimate of how much the mandrel weighs, and then they can select the proper slings to move it. Because this item is not symmetrical, they've also had to calculate the center of gravity in order to know where to place the slings so the mandrel is level.
Just a lift like this, you have to take a lot of things into consideration, like knowing the volume of a cylinder and how to figure that out, or how much a slab would weigh. So we have to do those calculations. If you want a challenging job, this is one under all kinds of conditions, so you've got to be prepared for that.
I'm Kevin Cantwell. I'm an MTM at the ArcelorMittal Burns Harbor plant. Preventative maintenance is great for fixing problems before they grow up into be big problems. If it fails, we could have several bearings go bad, cost a lot of downtime, cost a lot of money to get the parts to replace it again. So very critical keeping this up and running and get things fixed before they break. Today I'm out here running a route for one of our lube routes. This route today was just a daily route I go through and trying to maintain the equipment, and we found out that the tray bond system for the roll line quit working. So we don't have any grease going to the bearings right now, and we're trying to diagnose it, find out what went wrong with it, and get it back up and running.
Tray-bond auto greaser systems like this one are critical in order to ensure the mill runs smoothly. Kevin must know the right type of oil or grease to use in each system. He doesn't want to mix any of his lubrication. Lubrication helps reduce the shock to the bearing from a heavy load. This allows bearings to ride smoother and more efficiently by decreasing friction and increasing the life of the bearing. In extreme conditions, lubrication can also decrease the amount of heat applied to a bearing.
Watch the pins. So we're back up and running again. This is very rewarding when we actually run for long periods of time without any major breakdowns. If we can keep the bearings running nice and smooth and happy with the grease, then we can decrease the delay time and we can have more production coming out of the lines.
I'm Rich Repazinski. I'm an MTM at ArcelorMittal Cleveland. You need to know that in the classroom, what you're learning now is going to pay dividends once you get out into the mill. Okay, I got a work order today to prepare this shaft for a job out in the mill. Calls for a bearing and a gear coupling to be installed. I'm going to do what we call thermodynamics. The bearing and coupling doesn't fit as it is now, neither one. And it's designed that way. And the only way you can be able to get this on is to use an induction heater, heat it up, and it'll slide on. And when it cools, it'll be a nice snug fit. It's not going to go anywhere.
With his knowledge of thermodynamics, specifically thermal expansion, Rich knows that he can heat the bearing and coupler with induction heating, a process of heating an electrically conducted object, like metal, by electromagnetic induction. This will cause them to expand just enough to install on the shaft and complete the job.
So this is the induction heater. Now the bearing has to heat up to 250 degrees and the gear coupling 350 degrees. Slides on perfect. So now we're going to do the same thing with the gear coupling. Perfect fit. When this cools, it's going to be a snug fit and it's not coming off, trust me. Okay, we got a work order to install a spool piece to connect two ends of this water line. It's a 3-inch water line. It's flanged on each end, as you can see. These are 150-pound standard flanges. So the spool piece we're going to put in here and connect, drop in our gaskets, and show the proper way to tighten these up.
To do this job effectively, Rich will use principles of physics related to force, pressure, and torque. He must also select the right gasket replacement, bolts, nuts, and washers for the job. He needs to know the bolt they selected has the proper tensile strength, which is the maximum stress that a material can stand while being stretched or pulled before breaking. Rich also needs to know the correct torque specs for the bolts. Torque is the measure of the force on an object.
Now here comes the most important part, tightening it up. If I was to tighten it up the way it is now, you can see the spool sitting lower than here. If I was to tighten it up, you'd have a leak. So what we want to do is, I want to lift this up so you can see it's even. Now I'm tightening up the lower right bolt, snugging it up pretty good. Now I'm going to go to the top bolt, directly opposite it, and it'll draw the flange in equally. If I was to tighten up the bottom 2 bolts, and then go up to the top 2, you would have a gap somewhere and chances are it's going to leak. The final thing you want to do after you have your bolts tight is examine the gap between the 2 flanges. And I'm doing that and it looks the same all the way around. And this one looks pretty good. I'm sure when we put the water on, it's not going to leak. The last thing you want to do is go through all this, put the water on and start spraying like Niagara Falls. You don't want that. So yeah, there's a lot involved here, more than meets the eye. Today I was given an assignment to make a pipe run using 1.5-inch standard pipe. It's going to be threaded pipe as opposed to welded. And it has an offset in there. And I made my calculations and I know what size pipe I need, so now I'm getting ready to cut and thread my first piece of pipe.
To do this, Rich will be reading blueprints, making drawings, and performing calculations related to Euclidean geometry, specifically the Pythagorean theorem. He will also use trigonometry and algebra to measure the bends and length of the offsets to make sure that all of the proper connections are made.
Okay, this is the piece of pipe I just cut and threaded. I'm going to put a little pipe sealant on the threads and I'm going to install into the elbow. Anytime you make any kind of a pipe run, I don't care if it's an offset, a rolling offset, you need to know trigonometry functions, algebra. I use a Pythagorean theorem, and if you didn't and you tried to make this pipe run, you'd be going into it blind, you'd be cutting pipe and hoping it fit. I mean, that's not going to get you anywhere. Somebody in a classroom needs to know basic trigonometry, algebra, industrial math in order to do things like this.
I'm Roy Lucas. I'm an MTM at ArcelorMittal Burns Harbor. I can use cylinders to pick up 40,000-pound coils. I can pick up and move 10, 12-foot slab that's 10 inches thick. They weigh about 40,000 pounds, 50,000 pounds, and just move them like they're butter. I can do it with smaller equipment. So, hydraulics comes in handy. Okay, what we have is a shear system here. We have a clamp cylinder. It's going to hold my material in place so it doesn't move around. It's going to come down first. Pressure is going to build up. It's going to open up this valve, which is a sequence valve. It's going to allow this thing to go out this cylinder, and this cylinder will go out and shear my plate for me. And we want to slow this shear cylinder down, so we got to check and see what the speed of it is now.
Roy will use Pascal's law to determine how many pounds of pressure he will need to use for the hydraulics. Hydraulics use fluid because, as the principle of transmission of fluid pressure states, compressed fluid in a confined area is undiminished. Roy will adjust the speed by using Pascal's formula, which states that force equals pressure times area.
And that should give me a clean shear cut. Well, the MTM's role in this is that, we have to maintain the hydraulic system. That means our cylinders, our seals have to be checked and right. We have to maintain the fluid. Fluid has to be clean. We do everything from simple brake jobs on cranes, which is just a large automobile type deal, to, moving coils, lifting coils, pushing coils, the whole works. It changes day to day. My job is different today than it will be tomorrow and the day after.
I'm Jessica Roberts, and I'm an MTM at ArcelorMittal Wheelton. When you first start out working in a mill like this, it's a little intimidating. Cranes overhead, machines bigger than you could ever imagine. But once you get to know the place and know the people, learn how things work, it's really interesting. And today I'm going to fabricate a machine guard. I'm going to take a look at these blueprints I have here, lay out my lines, get my center, and get all my measurements correct, and then going to cut it.
Jessica will use her knowledge of geometry, trigonometry, and algebra to lay out the lines, angles, and curves for the machine guard.
What my next step will be is to actually make the cut. Another step in fabricating a machine guard is I'm going to have to make a weld. Before I make the weld, I got to determine what materials I need and how to set my machine. So I'm going to do what's called a magnet test.
For Jessica, it's critical to know the type of metal she is working with: ferrous, non-ferrous, or an alloy. That way she knows which welding process to use. In this case, she will use arc welding. Jessica's knowledge of geometry, trigonometry, algebra, and physics is what allows her to fabricate this important machine guard successfully.
You gotta have the skill basis so you can do things accurately. You can't take the time to, do it over and over again.
Our commitment to the environment is critical to our success as a steel manufacturer and being a good neighbor. We use many systems to remove hazardous materials from the environment. We want the world around us to be as good, if not better, than how we found it. Our future is bright, and with the skills you are learning today, you can join us in transforming tomorrow.
There's so many opportunities coming in as a new person straight out of school.
I like the maintenance because it's not the same thing every day. It's not repetitive.
We need craftspeople now. We're wanting people that are good in math.
Don't be afraid to get your hands dirty.
Being one of the youngest people in this steel mill, I hope to be here for decades.